Okay. So chapter 10 and 11 are basically looking at externalities in public goods. And so when we're trying to think, or when we're thinking about externalities, what we're really trying to solve is a market failure. And so basically, a market failure is just when the allocation of goods or services in the economy is not efficient. And the reason for that is basically a, a market economy, like the one we have in the US or the one, they have Canada. Frequently there are situations where a pure market, so where there's no government involvement, that is going to fail. The equilibrium in that particular sector of the economy or for that particular good is not going to reach the equilibrium that is best for society. And so usually that's caused because there's kind of some interaction between the individuals and companies in the economy that are pursuing their best economic interests, but those economic interests are not actually in the best interest of society as a whole. And so what I mean by that is basically when we're thinking about a negative impact, we can think about an externality. And so an externality is a really specific type of market failure. And it's basically just, so imagine like if you don't own a car and you live in any sort of city in the US because cars are everywhere, unfortunately, and you're negatively impacted by the fumes from cars. So because you're not a driver and you don't own a car, you're negatively impacted by other drivers, even though you don't own a car. And so because of that, that is a negative externality. So the negative externality of those fumes from cars, that negatively impacts you, even though you're not in that market. So basically, what an externality is just a negative or positive impact to individuals that are not in that market. And so externalities can also be positive. And kind of the example here is a beekeeper. So like when a beekeeper is keeping a hive of bees pollinate flowers. And so that benefits individuals who are, don't own any bees. And so because of that, that's a positive externality to society. So like the beekeeper is not the only individual that's benefiting from keeping bees. Other individuals in the area are benefiting by the bees pollinating their flowers. So those are kind of two real world examples of externalities and how they can impact individuals not in the market in a negative or positive way. So before we talk about and kind of get into how to calculate and think about externalities, it's important that we kind of refresh ourselves on welfare economics. And so for welfare economics, all we're really talking about is just the consumer surplus, so the green triangle, and then producer surplus, the blue triangle. So just remember that the surplus is this. So at a price of 250, so an equilibrium price of 250 and an equilibrium quantity of 25, this is the total surplus in this market. And this is basically the maximum amount of consumer and producer surplus in this specific market. So basically for welfare economics, we're just really talking about consumer and producer surplus. But the thing that's a little different now when we're thinking about externalities, and this is really important. So when we're thinking about externalities, the supply curve represents the private costs of production. So what does that mean? So basically the supply curve, so the supply curve in this example right here would be that line. So that supply curve represents the private costs of production. So these are the costs that are directly incurred by sellers. Whereas the demand curve, or in this case, that curve, is representing the private value of consumption. So basically the value to buyers of consuming the good. And you can also think about that, and I think we mentioned this pretty early on in the class, but basically their willingness to pay. So the demand curve is basically just a summation of all of the buyers' willingness to pay in this specific market. And so when we're talking about willingness to pay, basically all that is just the willingness of each individual consumer, the value that they place on potentially consuming the good. So for example, let's say that I value playing the Nintendo Switch at $300. And if that is not the if that is not the cost of a Nintendo Switch, if that's not how much I pay for one, then the benefit that I get from consuming the Nintendo Switch is basically the difference between what I pay and my own personal value of consuming or playing the Nintendo Switch. So that's basically all willingness to pay is trying to say, is that each individual values a good at a particular dollar amount. And that dollar amount may be greater than or equal to the price that is currently in the market for that good. So if there's a positive difference there, that is the consumer surplus. So in a really, really simple example, we have here an example where a city is trying to construct a new park. So this particular park that the city is trying to build costs $600 to build. And some people in the city are going to enjoy the park more than others. So in Lexington, each of the residents values this public good or a park at these prices. So Nancy values it at $60, Bran values it at $160, and Cairo values it at $180. So to determine the total benefit of the park, you basically just need to add together all of the surpluses. And it looks like Jin was supposed to be on there, but got cut off in the table. So let me add Jin. So when you add all of their values together, you get a total benefit of 620. So then we can see that if the park costs $600 to build and the total benefit is 620, then that would make sense that the city would construct the park because the benefits exceed the costs. But when we're looking at this kind of like the benefit calculation, we usually try to think about it in the sense of a value cost benefit. So basically like a cost benefit analysis. And the way we do that is just take the total value. So kind of like I talked about up here, just adding all together every single individual's willingness to pay, subtracting the cost of the park, and seeing if that is a positive number or a negative number. So if this is a positive number, that means it's good, you should build the park. If it's a negative number, you shouldn't build the park because there's not enough benefits to outweigh the cost. So that's obviously not how things get built in the US. There's not just kind of like this survey that's sent out to everyone in the area saying, would you like us to build a park? And if so, how much do you value this park? So what usually happens is taxes. So basically, when a government is trying to build something, frequently they will either create a new tax or use existing tax dollars to build something. So one of the ways that they can do that is basically take the cost of the park and then divide it by the number of residents. So then a good test of that is to see that, so basically let's assume there's like a public vote to see if this town should build the park. And if the majority of the population decides to vote for the park, it's going to be built. So we have the cost of 600, then divided by the number of residents, and that equals 150. So then all of the individuals who value the park greater than 150 are going to vote for the park. So then that means that Bran, Cairo, and Jin are all going to vote for the park, whereas Nancy is not, because her value of $60 is less than the 150 value or the cost of the park. So then in this case, in this specific example, the residents are going to vote to build the park. Now let's take a look at maybe a slightly more complicated example. It's still kind of the same process, but there's just a few more variables thrown in. So in this example, we're taking a look at 4 friends who are having a party and they're debating how many pizzas they should order. So a pizza costs $9 for medium pizza, and everyone is going to show their willingness to pay for each pizza. So then the question is, how many pizzas should they order? So if the cost is $9 per pizza, you just have to add up the first pizza, the second pizza lines, third, fourth, and fifth. So you can see then that the first pizza is going to be purchased. So is the second, so is the third, so is the fourth, but the fifth is not, because the $8 of value is less than the cost of the pizza. So then when you're thinking of how many pizzas this particular party is going to want, the fourth pizza is the final pizza where the willingness to pay is greater than the cost of the pizza. Okay, and I'm going to pause here and see if there are any questions before I move on. Yeah, and so these slides are on Blackboard in the course documents folder, chapter 10 and chapter 11.
Professor, can you go back to the previous slide?
Yes.
Yeah, I just have a question about what does the number 150 represent in this situation?
Yeah, no, so that's a really, really good question. So the number 150 here basically represents if the total, so if the cost to build the park was divided among all of the residents. So in this case, it's like a very small example, but there are only 4 residents. So we're basically just seeing if each resident had to share the average cost of building the park, would that cost be greater than each individual resident's value to build the park? And so we can see that that's true for 3 of the individuals, so Bran, Cairo, and Jin, but not for Nancy.
Okay, thank you.
Did anyone else have any other questions before I moved on? Okay. So kind of digging into the example we were talking about a little bit more of the pizza. So we can basically kind of think about this as breaking it down even further. So we have the cost per pizza, which we're given from the question. We know that there were 4 pizzas that were purchased based on the willingness to pay versus the cost. The total cost of the pizza then is just going to be the 9 times the quantity. And then the cost per person is going to be $9 per person. And so basically, we're kind of just trying to think about here, what is the costs for each individual person of ordering 4 pizzas? So we're basically kind of like backtracking to see if the total cost per person is greater than their willingness to pay. So like, for example, if we summed up all of Van's willingness to pay for the first, second, third, and fourth pizza, we can see that this would clearly be greater than 9. So in that case, ordering 4 pizzas makes a lot of sense, because the cost per person is significantly less than the willingness to pay. So the interesting thing, though, is that we also should think about how do we compute consumer surplus. So in this case, let's do it for France. So the question is asking us, so what is France's consumer surplus when 4 pizzas are ordered at a price of $9 per pizza? So we basically just sum up all of France's willingness to pay for the 4 pizzas. So basically just the 14, 10, and 2, and 0. And that's going to give us 26. And then the cost of a pizza to France, which in this case is going to be $9. So then France's surplus of consuming those 4 pizzas is going to be $17. And so basically, when we're trying to think about willingness to pay, it's really important to remember that it's not just kind of this superficial overview up here, where we're just kind of looking at everyone in aggregate. We need to really be able to drill down and understand the cost per person of pizza or whatever good we're talking about, as well as each individual's surplus. And yeah, I think someone has their hand raised, so feel free to unmute yourself or type into the chat.
Professor, so if his willingness to pay for 4 pizzas is $26 and 4 pizza would be 36, how would he have a surplus if you only use the cost of 1 pizza?
Yeah, so that's a really good question. And so this cost right here is the individual cost to France in the group of consuming the 4 pizzas. So we're basically taking, let me zoom out a little bit. So we're basically taking this number here and plugging it in here, because basically that is France's individual cost if the group consumes 4 pizzas.
So the $9 per pizza is also like the same as like $9 per person?
Yes, yeah, exactly. Yeah, in
Okay.
this question, it's kind of like a pure coincidence that those numbers are the same. They definitely won't be all the time. Yeah, let me draw an arrow too to kind of show how those are connected, just so that's a little more clear. And so when we're thinking about questions like this, it's really important to remember that if you're asked for an individual surplus in like a group situation, that you have to break it down not based on like the cost per pizza or the cost per whatever that's given by the question, but you actually have to see how many units of the good are purchased and then compute the cost per person of the group consuming that amount of the items. So in this case, that's the $9. And then that's what you need to use to determine each individual surplus. Yeah, and it looks like there's a, yeah, so if you have a question, feel free to type into the chat or unmute yourself.
I'm still a little confused how to read the chart. Is that, it's not the surplus, but if it's like, say Carlos is on his second pizza, he's willing to pay 16 for both of those or for his second slice only?
So this would be Carlos's willingness to pay for his second pizza.
Okay, so as they want less of it, they're willing to pay less of it.
Yeah, and like I think a really good example of that is, so like imagine that you were given the ability to basically like consume an unlimited amount of ice cream cones. So let's say like you went to Baskin Robbins and they said, you can consume as much ice cream as you want. So like at first, your willingness, the value or the willingness to pay of the first ice cream cone is going to be really high. But like as you consume more and more ice cream, that's going to decrease. And at a certain point, it might even turn negative because like if you eat more ice cream, you might get sick. So that's kind of what's behind that principle, is that the first item you're going to value very, very highly. And the more you consume of an item, you're going to have diminishing returns. Basically, because the more you consume, you're not getting that same initial benefit as you got before. Yeah, so it's basically, yeah, you can think of the willingness to pay charts as like individual demand curves. That's a good way to think about it. And then for the market, you basically sum all of those up to get the total amount. So like if you were trying to find what was the, the market demand for these individuals for the first pizza, you would just sum up Van, Carlos, France, and Winona's value for the first pizza, and that would give you the value of the first pizza to those individuals. Did that kind of answer the two questions that I had? Because I know it can kind of be a weird concept, but definitely let me know if that does not make sense. Yeah, so the 26 here, and let me highlight that. So this $26 right here is basically derived from adding up France's willingness to pay for 4 pizzas. So in that case, it would be the 14 for the first, 10 for the second, 2 for the third, and 0 for the fourth. And does that kind of make sense, or does anyone have any other questions? Because this concept will be very important for kind of some stuff we're going to do a little bit later. Yeah, and so the 36 was you found that by taking the cost per pizza and multiplying it by the number of pizzas purchased. And yeah, so for the surplus amount, basically what we're doing is we are taking the $9, the cost per person, and then just taking the 26 and subtracting it from the cost to that individual person of the 4 pizza consumption. And so for the 4 pizza consumption, what we're basically doing is we're just taking the France's willingness to pay for the 4 pizzas and just adding the willingness to pay for the first pizza, the second pizza, the third pizza, and the fourth pizza together to get the 26. Yeah, but so the important thing here is that the willingness to pay is less than 36, but remember that that is the total cost for the group. So that's not the total cost to the individual person, because in this group, there are 4 people who are willing to, or who are all equally contributing to the amount of money for the pizzas. So because it costs the total or the group $36 for the 4 pizzas, that costs each individual person $9. So we're basically taking the total cost per pizza, the 36, and then dividing that by the number of pizzas that were purchased by the group. which is 4 in this case. And then that gives us the individual cost per person of this specific, of the pizzas in this case. Awesome, okay. So let me move on to kind of a brief analysis of negative externalities. So when we think about negative externalities, what we really need to first understand is that a negative externality means that the existing equilibrium price and quantity in a market is not efficient. So the current equilibrium in a market is not efficient if that market has a negative externality. And so the important thing about negative externalities is that you need to internalize the negative externality, because if you don't internalize it, that means that market is not efficient. And so importantly, when you internalize that negative externality, this causes the supply curve to decrease along every single quantity. And so it's important to remember that negative externalities operate on the supply, not the demand. And so I know that can kind of be weird to think about, but I think it helps to think about what that looks like on a graph. So in this example, we can see that this is the original supply curve. But in the market for gasoline, there's a negative externality. So basically the cost of smog and the emission of greenhouse gases, that negatively impacts individuals who are not in that market. So because of that, there is a negative externality. And so what happens then when we internalize that negative externality is that we get a social cost curve, which is basically the sum of the private supply and the external cost. And in this example, the external cost is $1 per gallon. So what we basically have to do to find the new supply curve is just in every single price, we're going to increase that by $1. And so then that's how we get the new social cost curve. So if we're thinking about what that looks like with demand, then we need to think about what is the appropriate market equilibrium in this market for gasoline when we internalize that negative externality. So remember, before we had the original supply curve here and the original demand curve. And so this is our original equilibrium. But when you include the negative externality, that's going to shift the supply curve to the left. And it's going to shift it by $1 at every single quantity. So what that does is that actually shifts the new equilibrium. So notice now that the price is higher and the quantity is lower. So what we know then about negative externalities is that the price of a good in a market with a negative externality, originally the price is going to be too low and the quantity is going to be too great, which is at this point right here. But when we internalize that, that actually moves us to this point right here, which means that we are consuming the socially optimal quantity and price. So basically, what we're trying to do with the negative externality is decrease the quantity in the market because the current quantity is not efficient. So there are also positive externalities though. And so when we're thinking about positive externalities, basically what that means is just that the existing kind of same scenario, the existing price in quantity is not efficient. But when you internalize the cost of a positive externality, that actually causes the demand curve to increase along every single quantity. And the reason for that is because positive externalities are operating on demand, not supply. So positive externalities are demand, negative externalities are supply. So what does that look like then? So in this case, we can see that there is a positive externality in this market. And the positive externality is causing the demand curve to shift. And it's causing the demand curve to shift up by $10. So we can see that at every single price, the demand curve is shifting up by $10. So what happens then is that in a market with positive externalities, the price should be higher and the quantity should be greater than it otherwise would be. And just kind of to fully reinforce that, if we calculate consumer surplus before and after the externality is internalized, so we have this is the consumer surplus before there is the externality the externality is internalized. After the externality is internalized, note we get this bonus, consumer surplus. So for positive externalities, that's actually really good, because basically that means that there is this benefit to increasing the quantity consumed in a market. Whereas for negative, it's actually better to decrease it because the current quantity consumed in the market is actually harming individuals that are not in the market. So then the question is, how do we get people to internalize the externality? So the really important thing here is that you have two different scenarios. So for negative externalities, you either have to tax the good or service to make market participants pay the social cost of consumption or production. And a really good example of a tax that a negative externality can have is like a carbon tax. So anytime you hear of talk of like a carbon tax, the reason why that is being proposed is because the current consumption of gasoline, petroleum, natural gas, that's too high for society. And so what a tax would do is it would increase the price and decrease the quantity of petroleum and natural gas consumed in the market. Whereas for a positive externality, it's actually the reverse. Because remember, when we're talking about positive externalities, the price is actually increasing because it's operating on demand. But because we want people to consume more of the good, what we should actually do is we should actually subsidize that. So basically, the government will give subsidies to consumers to allow them to increase their consumption without having to pay any additional money. And a good example of this is like, so healthcare. So it's really, really good when people have health insurance, and we want everyone to have health insurance, or a lot of, not to bias anything, a lot of people want everyone to have health insurance. So one of the ways that the ACA, or the Affordable Care Act, did that was basically subsidize insurance for people. So the government said, we're going to give you money if you purchase health insurance. And we want you to have health insurance because that is better for you and for the country. So that's kind of one way that a positive externality, a real world example of that. And then importantly, both of those scenarios alter the normal market equilibrium in price, but they alter it in a good way. So this is not, like before where we were talking about taxes and deadweight loss. This is actually very positive. We want the goods with negative externalities to be taxed, and we want goods with positive externalities to be subsidized. Yeah, so like, exactly, yeah. So like for electric cars too, that's a really good example. So like in a lot of states, there are positive benefits, like the government gives you money to buy an electric car. And so that is one of the reasons, that's another good example of a positive externality. So like the government's going to say, hey, we're going to subsidize the cost of this good for you to purchase it, because we want people to buy electric cars because it's better for the environment. And then just kind of a little like summary of externalities that I included here. So this is good if you kind of like want to, after the lecture, go back and look at the slides and say, what is like a really, really high level view. This is a really good slide to kind of give you a very, very brief summary of externalities. Okay, and I do remember I had a lot of questions about the Coase theorem. So the Coase theorem is kind of somewhat related to externalities, but also somewhat separate. So the Coase theorem is basically the idea that private parties can bargain without costs over the allocation of resources. So all that's really saying is that for private markets to achieve an efficient outcome, when there are externalities, there has to be some sort of right associated with those externalities. So like in this example here, we have two neighbors, so John and Kathy. John plays loud music all day while Kathy is trying to work. So let's say that in this example, Kathy has a legal right to peace and quiet. So there is she has the ability to basically say her apartment building or whatever, says that you are not allowed to play loud music or something vague like that. So John values playing loud music at $600. Kathy values quiet at $1,000. So what happens? So in this case, because Kathy has a legal right to peace and quiet, she is actually going to pay John to stop playing music. And so she is going to pay John somewhere between $601 and $999 to stop playing loud music. So basically she has to pay John greater than he values playing loud music. And so when she does that, then the Coase theorem would predict that they're able to solve this problem without having the government involved, because there is a clear legal right. So in this case, Kathy has a legal right to peace and quiet. Does anyone have any questions on this one, or on the Coase theorem in general? Okay. So now let's flip that though. Now let's say that rather than John valuing loud music at 600 and Kathy valuing quiet at 600, let's flip those values, and then also let's flip who has the legal right. So in this case, now let's say that John has the legal right to play loud music. So John values playing loud music at $1,000. Kathy now values quiet at 600. So now what's going to happen? So now, because John has the legal right to play loud music, and this should actually be reversed. So now John is actually going to pay Kathy to allow him to continue to play music. And I'll update these before or after class as well. I apologize. So the important thing here is just to remember that when looking at the Coase theorem, you really need to first determine who has the legal right. So the question will always tell you an individual has a legal right. The second thing is look at what are the values that each individual places on their particular thing. So in this case, John playing loud music and Kathy valuing quiet. And so in this case, because the scenario is reversed, John is actually going to pay Kathy to continue to play loud music. And John is going to pay Kathy somewhere between $601 and $999 to continue to play loud music. So basically it all depends, and this is kind of the point of the Coase theorem, is that it all depends on who has legal right and what are the values that each individual has in this particular scenario. So that's how you determine the outcome of the Coase theorem. Okay, but of course, that's not always a great scenario. You can't always get the Coase theorem to work. And so usually the Coase theorem is unable to work when transaction costs are present and when the costs of coming to an agreement and following through on a deal are greater than the overall value that each individual has. So just the important takeaway is the Coase theorem is not always the solution. And it very infrequently is for big things like global warming or kind of other scenarios like that. It's not possible to solve those through Coase theorem. Okay, so the important thing when we try to think about externalities is that there are really two types of public policies towards externalities. So the first is either a command and control policy. And so this is where the government actually says, you are, as a company, allowed to emit X number of units of pollution. Whereas the second example is basically the government will provide incentives to individuals to solve the problem on their own. So in some cases, that can be things like tradable pollution permits, which are kind of like an example of what the EU and California are doing. So the government will sell off carbon permits, and then companies have to buy those, and the companies that buy them are allowed to continue to pollute. Or a corrective tax. So basically, the government will tax the negative externality or subsidize the positive externality. So those are the two examples for how the government can deal with externalities. Okay, so let me stop sharing, and then why don't we try one of the questions in Top Hat. Okay, so this is a example that is similar to the willingness to pay. And this is kind of why we started with willingness to pay, basically because what this is asking is, so what is the total cost of eliminating 2 units of pollution? And so what we're given here is 4 different firms and their costs to eliminate the first unit, second unit, third unit, and fourth unit. And so calculate the total cost of eliminating 2 units of pollution. That's basically what the question is asking. And feel free, if you have any questions, to let me know. And I'll give you all maybe like a couple minutes to compute this. Oh, and I'll just add really quickly, this is definitely an example of something you could see on an exam. Okay, I'll give maybe another minute to a minute and a half, and then we'll review the question's answer. Okay, and if you have not answered yet, make sure to answer, and I'll end it like 15 more seconds. Okay, so it looks like everyone has answered, so I'm going to close the question, and then we can review the answer. Okay. Oh, interesting. Okay, good. I'm really glad I asked this question then, because that is a important question, and we'll go over that right now. Okay, so for this question, the really important information is right here. So what if the government requires that each firm eliminate 2 units of pollution? So the important way to look at this table, and I know these tables are kind of weird to think about, but so this row right here is the cost to each individual firm to eliminate 1 unit of pollution. So it costs firm A $50 to eliminate 1 unit of pollution. Whereas for firm B, it costs 27. And for firm C, it costs 54. And D, it costs 62. So the next thing then, so if we go to this row and we're thinking about the second unit, so for firm A, it costs $72 for them to eliminate the second unit of pollution. Whereas for firm B, it costs $50 to eliminate the second unit of pollution. So the way you want to calculate and think about this question is when it's asking you, what is the cost to eliminate 2 units of pollution? You basically have to add up these 2 numbers for firm A, these 2 numbers for firm B, these 2 for C, and then these 2 for D. And then that gives you the total cost of pollution elimination. Does anyone have any questions on that? Okay. So when we're thinking about pollution elimination, remember, there are 2 ways to think about it. So command and control, which is this question right here, is an example of command and control. The second option, though, which we have not yet discussed, is the market-based policy. So this question right here is an example of a market-based policy. So in this case, it's going to ask you, what if the government charged a tax of $82 per unit of pollution, what would the cost be? What would the total cost be to the firms of eliminating pollution? And so the way you need to look at this question is somewhat similar, but importantly, very different than the prior question. So the prior question was just saying, what is the total amount of pollution elimination? And then they gave you, each firm is going to eliminate 2 units of pollution. In this case, now we're given a dollar amount. And so because we're given a dollar amount, we need to take a look at each firm's cost of pollution elimination and see how they're going to eliminate pollution. So the way you can think about this is that basically, if a firm has a cost that is less than the tax, the firm is going to eliminate that unit of pollution. So what we can look at then is, so if we say $82 tax, what is the pollution that each firm is going to eliminate? So A is going to eliminate 50 and 72, because that is less than the $82 of the tax. So they're going to firm A is going to eliminate 2 units of pollution because their first unit of pollution cost them $50 to eliminate. The second unit of pollution costs them $72 to eliminate. So for firm B, we will do that same calculation. So 27, they're going to eliminate that, and 50, they're going to eliminate that. And we'll do the same thing for firm C and D. So C, they're going to eliminate 3 units. In D, they're only going to eliminate 1. So the important thing to note here, though, and this is why economists usually favor taxes rather than command and control, is that the total cost of pollution elimination here is $469. And they're still eliminating 8 units of pollution. Whereas before, they were also eliminating 8 units of pollution, but it cost $480. So that's one of the reasons why taxes are generally preferred by economists rather than command and control, because taxes allow for firms to determine which is more efficient for them to eliminate, rather than telling every single firm you have to follow the same pattern. Because note that firms have different costs of pollution reduction based on how they produce goods. So just kind of an important note there that these questions definitely could appear on an exam as well when they're asking about pollution elimination, either version of these questions. Okay, in the final piece for chapter 10 and 11 is thinking about goods that are kind of like basically how to classify goods. And we have 2 different kind of initial categories. So we first have excludable. So a good is basically excludable if a person can be prevented from using it. So like think about a good is excludable if you can stop someone from using it. So like a hamburger, if you have a hamburger, another person can't have it unless you give it to them. So that is an excludable good. A movie theater is also an excludable good. So like if a movie theater is full, then you cannot go to that movie theater. So that's another example of an excludable good. Whereas not excludable are things like coal or national defense. National defense is kind of a weird one, but basically that's the idea that everyone in the United States is protected by the Department of Defense. Basically, like if another country tries to launch a nuclear missile at the United States, basically the shield that the United States has, so like missiles to intercept that, everyone in the US is protected from that. attack. So that's an example for national defense. Another one is like minerals, so like coal. So someone can't own all of the coal in the world. So because of that, it's not an excludable good. Whereas something something can be not excludable if you're thinking about, I'm trying to think of another example because I feel like those are not super great. Maybe something like a park. And so maybe think of this in the case of like a really, really big park that doesn't really get to capacity. So maybe like Central Park. So Central Park really isn't excludable. You can't really exclude people from going into Central Park. Okay, and then the next category is rival and consumption. And so all that basically means is that if I consume the good, that means that you can't consume it. So like a hamburger or coal. So like if I eat a hamburger, you can't eat that hamburger because I've eaten it. The same is true of coal. So like if I burn a piece of coal, you can't also burn that same piece of coal. Whereas not rival is something like national defense or a movie theater. So for national defense, like if I'm protected from a nuclear attack and I live in the United States, then you can also be protected from a nuclear attack in the United States if if that happens. So those are just kind of the two general categories for goods. And then we get more specific when we're thinking about categories of goods, and we classify them into 4 different types. So we have private goods, which are excludable and rival in consumption, public goods, which are not excludable, not rival, common resources, which are not excludable but rival, and natural monopolies or club goods, which are excludable but not rival. And I'm not going to like hammer these in because I think the kind of the slides do a better job of kind of describing them. But basically, why we're talking about this is because when we're thinking about externalities, goods that do not have prices are impacted by externalities. And so that is basically public goods. So public goods are goods that are difficult for the private market to provide. And this is due to the free rider problem. And I feel like a lot of you might have already heard of this. And basically a free rider problem is where you receive a benefit of a good, but you don't pay for it. So like if the good is not excludable, you can't exclude people from consuming the good. But if it's a public good, then the good is available to everyone. So because of that, there is this potential for a free rider problem where people receive benefits of the good, but they don't actually pay for it. And the most common example of that are the goods that are called common resources. So basically, these are goods that you can't prevent people from using them, and private companies have no incentive to provide them. In a really, really good example of common resources are things like deforestation or overfishing. So basically, the government, each individual government in the world doesn't have full control of the ocean. So because of that, there is no way for for people to actually prevent overfishing, because it's a problem that you can't exclude people from fishing. And so because of that, it's really hard for the world to solve this problem. Climate change is another really good one, actually, because a good example is like countries that are in the Northern Hemisphere. So like the United States, Russia, and Canada, we actually won't be impacted as much by climate change as a lot of countries along the equator, but we are actually the biggest polluters by a significant margin. And so because of that, we don't actually have an incentive to stop polluting as much as some other countries do, even though we're the biggest polluter, or second biggest now. But because of that, we actually are don't have as much of a push to stop polluting because it's not negatively impacting us as much as it is other countries. So that's kind of the problem of common resources. And one of the reasons why solving that problem is really, really difficult.